Okay, class, we will start to look at the questions. Okay, so for this questions that we have we have 4 questions here. So they are asked a bit differently because they are from Edexcel, they are from different exam board. So the thing is, when we actually try to work with the series, okay, they are actually the same idea. So basically for the Maclaurin series is a special case for the Taylor series. Taylor series is more like a more general one. Maclaurin series is a more specific one. Okay, so all the questions that can be done by using a Maclaurin series. So basically, for Maclaurin series, what does that mean is we are trying to find out what is the value, okay, for the n derivative when we have like x equals to 0, okay, and we actually form a series by using those values. Okay, it's not really difficult to do. So it would be the thing would be we have to be careful when we actually differentiate some expression that is quite complicated sometimes, and we have to rely on different derivatives, the n derivatives, to actually differentiate some more. Those kind of thing is the thing that we have to be careful of. So okay, for this one, okay, let's look at the first question here. So we have got the displacement of x meters, okay, for this is given by this differential equation. So in this differential equation, they already have the second derivative of x and also x, okay. So here it is not y and x, but it would be x and t. So x is a dependent variable and t will be the independent variable here. So and say, okay, and they say when t equals to 0, x equals to 0, the dx dt is equals to half. So the next one is they ask us to find a series, okay, include the terms which is until t power 3. So if we want to get the term which is t power 3, we need to get the third derivative, means we need to get d cubed t over dt cubed in that case. Okay, so basically how do we actually get that is we just have to differentiate one more time, okay, from the differential equation that we get. So differentiating is not a difficult thing to do. So basically it will differentiate both sides, okay, with respect to t. So the first term d squared d squared x dt squared, when we differentiate one more time we get d cubed. Okay, so the terms after that will be differentiate an x, we get an dx dt, and this one is a cos x. So when we differentiate cos x, we get a negative sign, and we have to multiply by a dx dt because we are differentiating x but with respect to t. Okay, so with that we can actually have a complete relationship which actually gives us different values already. So what we have is we have when t is equals to 0, x equals to 0, so it helps us in finding the value for the second derivative when we have t is equals to 0. Okay, so the second derivative here, the dx squared dt squared, is by using the relationship, okay, or the equation that is already given earlier on. And for the third derivative, we will have to depend on this one. Okay, so just substitute any values which is related. We have got the dx dt, okay, is half, and also we have got x equals to 0, and also another one is the value for the dx dt here lah. So basically what we get for the dqx dt cube is negative 1 over 2. Okay, so after that, because we have got all these values already, we can actually write out the Maclaurin series for the x. Also the x will be in terms of t ma. So our x is equals to this is the value for this is the value for the x, okay, when t equals to 0. So this is for dx dt, this is for d squared y dt squared, so this is for d cubed x dt cube. So these values here are the values that are actually written there, and then just follow the formula, because we have got all the modulus in our denominator. Okay, so if we have the n derivative, and then the power will be the will follow the n, no? Okay, so basically this is what we get for the series. Okay, so that will be for the first one. All right, so we will actually look at the next question. So next question gives us a d squared y dx squared in terms of we have got x, y, dy dx, and so on. Okay, and we are supposed to find, we are supposed to show, okay, the d cube x is equal to this bunch of the expression. So basically it is not difficult to do, just that we need to be careful when we actually try to differentiate, because the left hand side is already d squared y dx squared, so we just have to differentiate one more time to get d cube. Okay, so d cube y dx cube is just differentiating the whole thing, which is the right hand side here. So there are something that we need to be careful of. We need to look at the term which we have got e power x times that whole bunch of thing. So if that is the case, we need to use the product rule. Okay, so let's say, okay, we use this product rule. So when we have the product rule, we fix, we differentiate the ex and then we fix this one. Or another term is we fix the ex and then we differentiate this one. So for the first term is easy. We just have to differentiate the e power x and then we will get the same expression again. Okay, but for the second term, we fix the e power x, but we are going to differentiate the terms, which is like we have got so many terms inside here. Okay, so we look at the the third term here first. So dx of 1, we get a 0, so nothing special about that. And we have got y squared, so when we differentiate y squared with respect to x, we get 2y dy dx. Okay, this is what we know. And the first one is a 2y times dy dx. So this one we have to use the product rule. So we again we use the product rule. So this one, the first one is we fix the 2y, we differentiate the dy dx. Okay, so that we get this d squared y dx squared. Another term, okay, is we fix the dy dx, but we differentiate the 2y. So differentiate 2y gives a 2 dy dx, which has to multiply with the earlier dy dx. So this is why we have got 2 dy dx squared in this case. So basically after that is to factorize out the e power x and then tidy up the terms inside. Okay, so it is good for us. They already give us the form that we should be expressed in. So if we actually compare what we have in the question and what we get here, the k is equal to 4. So basically they are looking at this value here. So this is our value for the k. Okay. So the next one is, okay, given that we have got x equals to 0, y equals to 1, and then also the dy dx is equal to 2, so we need to find this series up until the x power 3. Okay, so for x power 3, we have we need to find out all the values when we have x equals to 0 for the d squared y dx squared and also the d cube y dx cube. Okay, so it is already given, okay, x0, y is 1. We can use the given relationship, okay, earlier in the first line, okay, to get the value for the d squared y dx squared. For the d cube, it is already also shown here. Okay, so basically the d cube is again substituting all the values in, just basically throwing all the values, calculate them carefully, and we will actually get the 30 from there. So for the series for the y is basically just using all the values for the y, dy dx, d squared y, and d cube y dx cube. Okay, divide by their modulus, sorry, not modulus, the factorial, and with the respective power for the x. So from there, we just have to form the Maclaurin series from there. So it is not a difficult thing to do. Okay, provided that we have done everything carefully and correctly. Alright. Okay, so next one. Okay, next one is another similar thing given where we have this relationship between y, d squared y, and also dy dx. So the first one is to find the d cube y dx cube in terms of d squared y, dy dx, and the y. Okay, this one, okay. First one, okay, because we want to get d cube y dx cube, so we have to just differentiate this whole thing, okay, with respect to x, and we just have to work with that carefully. Okay, so what happened from there is we look at it term by term. Okay, for the first term, when we want to differentiate it again, we have to use the product rule. So the first term is obtained when we fix y, we differentiate the d squared y. Okay, second term is we fix the d squared y and we differentiate the y, so that's why we get the dy dx here. Okay, for the second term, dy dx the whole thing squared, so we have to differentiate it like we have the expression which has a power. So how do we differentiate this kind of the expression is that we move down the power, so that we get a 2. Then this one, dy dx, only has a power 1, which is here. And we need to multiply that term by differentiating whatever which is inside the bracket. So inside the bracket is dy dx. Differentiating that, we will get the d squared y dx squared from there. And 5y, differentiating, we get 5 dy dx. Basically here is just to tidy up everything, okay? And because they need the d cube y dx cube in terms of all this, so just have to rearrange them nicely lah. Okay, make sure we really give the d cube y dx cube as the subject. Okay, so we are so we can actually have the first part. Okay, basically for part B, find a series solution for y. Basically what they actually mean here is they need us to find the Maclaurin series. Okay, they just ask the question differently. So just sum in all the values for x equals to 0, y equals to 2, and then it is also given that the dy dx is equals to 2. So from the given relationship, find the d squared y dx squared. Okay, so the d squared y dx squared is a -7 in this case. And for the d cube y, we already found it here. Okay, so for this d cube y, we just have to substitute the previous values lah. So substitute the previous values in, we will actually get 16 from there. Okay, so with all these values, okay, for the derivatives, okay, it is not difficult for us to find this Maclaurin series. Okay, basically Maclaurin series is not difficult to do. Okay, all right. So that would be the third question. Okay, let's just look at the last one. Last one is even simpler. So for last one, we have got d squared y dx squared plus 4y minus sine x. So this is we have to find the term until the x cube term. So basically, we just have to differentiate one more round from that. Okay, so differentiating this is not difficult at all. It's rather simple, because for all the terms here, when we are trying to differentiate it, it is not difficult. There is no product rule or quotient rule involved here. So basically everything is quite simple. So we have got x0, y half, also dy dx is also given. We can find out what is the value for the d squared y dx squared, okay, by using the equation given in the first line. And to find the d cube y, we just have to use this relationship. So substitute all the necessary values, and we should be able to get the d cube is a half. Okay, so after that, just put everything, okay, into the Maclaurin series, and that is what we will get for the answer. Okay, so just have to be careful by working with the values, and basically that's it. Okay. Okay, so I guess that's all for today. For tomorrow, we will look at some questions from the integration, okay, from the Edexcel syllabus. So later I will upload the question for you, and you can try it, and we will discuss tomorrow at 3 p.m. Okay, so I'll see you tomorrow. Thank you.